Hello, everybody, and welcome to this week's lesson. This week we are on Unit 3. We are talking about fractions and decimals, building on what we've learned in the last 2 weeks about the number system, about ratios, and about fractions. Materials you'll need for today, you'll need your welcome packet, as always. Pencil and paper, a calculator might be useful. And you might find your lesson notes from the past few weeks in August helpful as well. All right, so we're going to get started with a couple warm-up problems. Number 1 says, which digit is in the 10th place in 1.75? So this is a little review from a couple weeks ago when we talked about place value. If you're not sure, you might find it helpful to take out your welcome packet and turn to the place value chart in there. So that might give you a little hint. So which digit is in the 10th place in 1.75? Well, we've got our decimal point right here. And so that means when we move past the decimal point to the right, we've got the 10th place. So we would say the 7 is in the 10th place. This number is telling us we've got 1 whole, we've got 7 tenths, and we've got 5 hundredths. All right, number 2, compare the fractions below using less than, greater than, or equal to. So we've got the fractions 5/6 and 14/18. We want to know, is 5/6 greater than, less than, or equal to 14/18? So what do? Well, one way to compare fractions that we practiced last week was to find a common denominator, right? Fractions are easier to compare if they have the same denominator, because the denominator gives us information about how big the parts are, right? Fractions are a comparison of a part to a whole. So we want to find a common denominator. We have a denominator of 6 and we have a denominator of 18. What is the least common denominator for 6 and 18? What is the smallest denominator that they will have in common? Well, to determine that, we think about the least common multiple of 6 and 18. So we think about multiples of 6. Multiples of 6 would be 6, 12, 18, 24, and so on. Multiples of 18 would be 18, 36, and so on. We can stop there because we already said a common multiple, right? The first multiple, or the lowest multiple that they have in common, is 18. So the lowest common multiple, and therefore the least common denominator of 6 and 18, is 18. So the LCD is 18. Well, that's kind of nice because one of our fractions is already in 18ths, right? 14/18, we've got a denominator of 18. That means we don't need to do any work on that fraction. We just leave it as it is. We will need to convert our other fraction. So, right, when you're trying to compare fractions by finding the same denominator, first thing you do is you determine the common denominator. Second thing you do is you need to change both of your fractions so that they have that denominator. Part of that work is already done for us because one of the fractions is in 18ths already. But we got to tackle that 5/6. So that's going to be our second step here. 5/6. We're going to raise that fraction. We're going to raise it so that it has a denominator of 18. When we raise fractions, that means we're multiplying the top and the bottom by the same number. So what do we need to multiply 6 by to get 18? We need to multiply by 3. So 6 times 3 is 18. We do the same thing up top. 5 times 3 is 15. So now, instead of comparing 5/6 and 14/18, now we can compare 15/18 and 14/18. So is 15/18 greater than, less than, or equal to 14/18? Well, it's greater than, right? 15/18 is more than 14/18. So we can say for our final answer that 5/6 is greater than 14/18. All right, so our learning goals for this week. By the end of this week, you will be able to order fractions and decimals, including ordering on a number line. So we're going to continue our practice with ordering and comparing numbers. We're going to throw decimals into the mix this week. You will also be able to add, subtract, multiply, and divide with fractions and decimals. So we're going to get a little bit of practice with each of those skills this week. First, let's do some review about ordering fractions. So reviewing what we just talked about in that warm-up problem. So one way that you can order fractions is to find a common denominator. So let's say we have the question, which fraction is larger, 12/15 or 7/10? Right, that's a very similar question to the one we just answered in the warm-up. So how would we answer that question? Well, first thing we do is we find the least common denominator. Right, first thing we do is we find the least common denominator, and the least common denominator is going to be the LCM, the least common multiple of your denominators. So what's the first multiple that your two denominators have in common? And I've listed here multiples of 10. I've listed multiples of 15. So the first multiple they have in common on their list is 30. So here, the least common denominator for 12/15 and 7/10 is 30. So next thing I do is I change both fractions. So however many fractions you're working with, you change them so that they have that least common denominator. And I'm showing you that here. So 12/15 times 2/2 will give you 24/30, right? So changing the 15ths into 30ths. And then same thing with 7/10. 7/10 times 3/3 will give you 21/30. So changing tenths into 30ths. And now finally, we are ready to compare our fractions. So we will start by comparing the raised fractions, the ones we just made with the common denominator. So 24/30 is greater than 21/30. And therefore, 12/15 is greater than 7/10. So our final answer, right, to answer our original question here, is that 12/15 is larger. That's our final answer. Okay, so as promised, we are going to be building on that work we did with ordering fractions last week. We're going to be throwing decimals into the mix. So I wanted to start off just by getting clear on what are fractions and decimals and how are they different from whole numbers. If you think back to when we talked about place value, right, we talked about how all of the place values to the left of the decimal point are whole number place values, and everything to the right of the decimal point are decimal or fractional place values. So what's the difference there? Well, it's partially built into the name, right? Whole numbers are talking about whole things. So whatever it is you want to talk about, it's whole objects, things that have not been broken down into little pieces. So that's whole numbers. Whereas fractions and decimals are talking about parts of a whole. So fractions and decimals are two different ways of talking about the same thing. They're two different ways of describing a part of a whole, right? So a decimal number is a way of writing a part of a whole that fits into our place value number system, right? Where we have ones, tens, hundreds, tenths, hundredths, thousandths. Whereas fractions, right, are a way of writing a part to a whole where we set it up as a comparison, right? We have a numerator and a denominator. So fractions and decimals are very similar. They have the same goal, which is to describe a part of a whole. So let's say we have a group of numbers, a mixture of fractions and decimals. How would we put them in order? How would we compare them? Well, there's two ways we could do it. Right, if we have a mix of fractions and decimals, one way we could do it is to change everything to a fraction and then change them all to the least common denominator and then put them in order. And that's what we have practiced already, right? We practiced changing fractions to a least common denominator and using that to help us put them in order. The second way you could do it is you could change everything into decimals. So you could just take all your numbers, you could make sure they're all decimals, and then you could order the decimal numbers. So what we're gonna do today is we're gonna get some practice with that second strategy. We're gonna get practice with changing things to decimals and then putting all those decimal numbers in order. So we have a fraction. How do we change or convert it to a decimal number? To change a fraction to a decimal, we just divide. So it's the numerator divided by the denominator. It's the numerator divided by the denominator. And I've got the example on the screen here of 2/5, 2/5. If we want to take 2/5 and change it into a decimal, what we do is we think of it as division. So we think to ourselves 2 divided by 5. Sometimes people have trouble thinking about how it's possible to take like a smaller number and divide it by a larger number. It might help you if we think about it as like money. So if you have $2 and you want to split it up equally amongst 5 people, how much money is each person going to get? So that's what we're talking about here when we say 2 divided by 5. So 2 divided by 5, when we do that division, what answer do we get? We get 0.4. So the fraction 2/5, or 2 out of 5, means the same thing as the decimal 0.4. Now you can do that on a calculator, but let's also take a look at the long division. Let's try doing it by hand. So I have the long division set up right here. Okay, we're doing 5 into 2. How many times does 5 go into 2? Well, it can't, right? It goes in 0 times. So what I need to do is I need to add a decimal point after my 2 and a 0 after that decimal point. Now, why do I do that? Well, I'm really just taking advantage of the fact that 2 means the same thing as 2.0 or 2.00 or 2.000, right? I could keep going with my zeros there. But if you have a whole number, the decimal point and the zeros after the decimal point are always there. We just don't bother writing them all the time. So here I'm going to write them. I'm going to make use of them. So 2 becomes 2.0. And now I'm going to take my decimal point and I'm going to bring it up to my answer so I don't forget about it. The decimal points should always be lined up. So that decimal point comes right up to the answer. Now I can ignore my decimal point. I don't need to think about it anymore. And I continue dividing as usual. So 5 goes into 20 how many times? Well, 5 goes into 20 4 times. And 5 times 4 is 20. And 20 minus 20 is 0. We're out of numbers to bring down. We have no remainder, so we know we're done. We know our final answer is 0.4. So to convert a fraction to a decimal, you do the numerator divided by the denominator. So let's get some practice here with using that strategy to put these numbers in order. It says write the following numbers in order from least to greatest. So we have 5 numbers here. It says 1/2, 0.1, 5/4, 0.25, and 3/4. Now, if you are already kind of comfortable with your fractions and decimals, you have a lot of experience working with them, you might be able to look at these numbers and confidently put them in order from least to greatest without writing out all of the conversions from fraction to decimal. But I'm going to go ahead and just write everything out so we can all be clear on how to put these fractions in order. So I look at my list of numbers. I see I've got a mixture of 2 different types of numbers. I've got fractions and decimals. So first thing I'm going to do, I'm going to make my life easier by changing them all to the same type of number. And in this case, I'm going to decide to change them all to decimals. So I'm going to take each of my fractions and change them to decimals. So 1/2, 1 divided by 2. You have $1 and you need to split it equally amongst your 2 friends. Each friend is going to get $0.5 or 50 cents, right? So 1 divided by 2 gives us 0.5. On to my next fraction, we have 5/4, 5/4. So if you have 5/4 in your pocket, how much money do you have? You have $1.25. So 5 divided by 4 is 1.25, 1.25. And that should also make sense because if you think about how many quarters, how many fourths there are in one whole, right? There's 4 fourths in one whole, but we're talking about 5 fourths. So that's a little bit more than one whole. So we would expect our answer to be 1 point something. All right, and on to our last fraction here. We've got 3/4 or 3/4. Well, you got 3/4 in your pocket. How much money do you have? You have 75 cents in your pocket. So 3/4 is the same thing as 0.75. Okay, so now I've got all of my fractions written as decimals. And then I've also got my 2 decimal numbers here that I don't want to forget about. So we want to put these in order from least to greatest. Now, when you are ordering numbers, so be it whole numbers or decimal numbers, what you want to focus on is comparing matching place values. Now, this is already something that you do probably without really thinking about it when you order whole numbers. But sometimes it can be a little tricky to remember to do that when you're ordering decimals. So let me show you what I mean. If we have 0.1, I'm just going to start with the 2 original decimal numbers here. We have 0.1 and we have 0.25. I don't want to compare this by thinking about it like 1 compared to 25, because that's not what we're talking about here. When we have 1 compared to 25, what you're doing in that situation is you're comparing the ones place. So you've got a 1 in the ones place here, you've got a 5 in the ones place here, and then you've also got 2 in the tens place, right? So there, you are aligning your place values before you compare. We want to do the same thing with our decimals. So we don't want to compare them like this. We want to align our place values. That would be like this. So 0.1 and 0.25. So I've got my ones place lined up and matching, and I can see that those zeros, right, are both in the ones place. My decimal points are lined up. My tenths place is lined up. And then I just got the 5 here in the hundredths place. If you wanted to, you could actually fill in that missing space at the end of 0.1. Some people find it helpful to fill in those missing spaces. You could think of this as 0.10. And then it becomes a little bit more obvious that instead of this being similar to comparing 1 to 25, it's actually more like comparing 10 to 25. Okay, so now let's do that with all of our decimal numbers here. Let's line them all up. And now again, once you get comfortable with this, you might not need to write them all out, line them all up. You might be able to do this visual comparison a little more easily in your head. But we're gonna do it on the paper for now so we can all get comfortable with it. All right, I'm gonna start with the first number on my list here. It was 1/2, which is 0.5. So I'm gonna line all my numbers up, 0.5. The next thing from my list was 0.1. Next thing was 5/4. So 5/4 is 1.25. And then we had 0.25. And then 3/4, so 0.75. Okay. And now typically when you're comparing numbers, what you do is you start with the largest place value and kind of work your way down. Again, this is something that you probably do already with whole numbers without really thinking about it because you've been doing it since you were a little kid. So let's start with the largest place value that we see here. The largest place value I see is the ones place, right? To the left of the decimal point, we've got our ones place. I look down my list, I see 0 1s, 0 1s, 1 1, 0 1s, and 0 1s. So that tells me that 1.25 is bigger than all my other numbers because it's got one whole there and none of the other numbers has one whole. So I'm gonna put 1.25 at the end of my list because we're trying to go from least to greatest. So I'm saying that this is the greatest or the largest number. Okay, so that's taken care of. Now let's move to the 10th place, the next smallest place value. I look down the list, and remember we can ignore that 1.25. So I look down the list, I got 5/10, 1/10, 2/10, and 7/10. 7/10 is more than the other ones, right? 0.75 is bigger than 0.25 or 0.1 or 0.5. So 0.75 is going to come next. All right, so we got those two taken care of. Now we're going to continue looking at our 10th place. So we had 5/10, 1/10, 2/10. The 5/10 should come next, right? 0.5 is bigger than 0.1. It's also bigger than 0.25. And then next is going to be that 0.25. Next smallest. And finally we get to 0.1. That's going to be our smallest number. So that is the list of our numbers in order from least to greatest. And I'm just going to go ahead and I'm going to put my fractions in my list as well, just so that we don't forget that we started out with fractions. So 0.5, that was 1/2. 5/4 was 1.25. And 3/4 was 0.75. So our final list should really be 0.1, 0.25, 1/2, 3/4, 5/4. At the very least, when you're putting numbers in order, numbers that are greater than 1, right? So if you see like 1 point something or 2 point something, or if you see, sorry guys, my cat was just trying to drink my tea, which is not good. So if you see a number that has some whole number component to it, something that is greater than 1, that should definitely be larger than any values that do not have a whole number component. So something that says like 0 point something. So just a very broad guideline to keep in mind, something that can help you double check your work at the end. All right, now let's get some more practice with this. Last week we got practice with plotting fractions on a number line. So we are going to extend that this week into our lists that have a mixture of fractions and decimals. So we're gonna take that same list we just had, that same list of numbers, 1/2, 0.1, 5/4, 0.25, and 3/4. And now we're gonna plot those numbers on this number line. So first thing I'm gonna do, whenever you're dealing with a problem that has a number line, you wanna take a little time to inspect that number line, check out the situation, see what you're working with. So when I look at my number line, I see it starts at 0 and it goes 0, and then I have 1 here, and then I have 2 here. And when I look between my whole numbers, I see it goes 0.25, 0.5, 0.75, 1, 1.25, 1.5, 1.75. So what are we counting by here? Each time we move up a space, how much are we going up by, would you say? Well, we can tell just from the starting at 0 and going to the first line, we can tell we're going up by 0.25. So we should be going up by that amount each time, right? 0.25, and then we go up 0.25 more, we get to 0.5, and then up 0.25, we get to 0.75, right? We're going up by 1/4 each time. So when you look at a number line, you want to check out what the interval is. So you want to check out how much do these spaces between the lines represent. And in this case, the spaces between the lines represents 0.25. So each time we move up, we're increasing by 0.25. Another way to think of that is we're increasing by 1/4, right? We're increasing by 1/4. Okay, so now let's figure out where these numbers go. Let's start with 1/2. Well, in the last page, we determined 1/2 meant the same thing as 0.5. We also talked about how you can add those zeros after a decimal number and it doesn't change the value, right? So 0.5, that has the same meaning as 0.50, 0.50. So I'm going to take my first number and I'm going to make a point here at 0.50, and I'll label that as 1/2. All right, that's my first number done. Second number is 0.1. So where do you think this belongs on the number line? Well, we know, right, that 0.1 from our list that we just made, 0.1, it was the smallest number on our list. It was less than 0.25, it was less than 0.5, it was less than all those numbers. So that means if it's less than 0.25, it belongs somewhere in here in between 0 and 0.25. Now, because of the way this is set up, we might not know exactly where it is in the space between 0 and 0.25. We might not know exactly where 0.1 belongs, but we can estimate, right? So if we have 0 and we have 0.25, where do you think 0.1 belongs? Well, it's going to be somewhere around here, let's say. So not quite halfway. It's not quite halfway to 0.25. going to be a little bit before halfway. So I'm going to put a point here, and I'm going to call this 0.1. All right, next number, 5/4. Well, what was 5/4 equal to? It was equal to 1.25. So I can go right ahead and plot that on my number line. Put a point right here, and we'll make it clear that that is also 5/4. Next up, we got 0.25. That's going to be easy to put on our number line right here. And I'll label it again just so we know it's one of our numbers. That does say 0.25, even though it does not look like it. All right, and then we have 3/4. Well, we saw, right, 3/4 or 3/4. Right, that's the same thing as 0.75. We will put that here on our number line. And there we go. We've got our 5 numbers plotted on this number line. And we can see again what those numbers look like in order, right? First we have 0.1, then 0.25, then 1/2, then 3/4, then 5/4. Okay, so now we are going to jump into our addition, subtraction, multiplication, and division with our fraction and decimal numbers. So we'll start with fractions, adding and subtracting fractions. Well, the first part of the process is really similar to what we've already practiced with comparing fractions. So finding the least common denominator, changing our fractions to have that least common denominator, and then we get to add and subtract. And finally, we simplify. So when we're adding and subtracting fractions, we always, before we get to add or subtract, we always have to make sure that the denominator is the same. Again, for the same reason, because the denominator tells us how big the pieces are that we're working with. So all of the pieces need to be the same size before we start combining them or pulling them apart. Okay, so let's start with example 1 here. Example 1, 1/4 plus 3/4. Well, now that one is kind of easy for us because they already have the same denominator. So we can skip the first 2 steps in the process and we can jump straight into our addition. 1/4 plus 3/4 is going to be 4/4. And then we always check and see if we can simplify. Can we simplify 4/4? Yes, we can. It will become 1, right? 4 out of 4 is 1 whole. All right, next example, 11/12 minus 3/4. Well, these fractions have different denominators. So before we subtract, we need to work through our steps. Number 1, find the least common denominator. So the least common denominator of 12 and 4, it's going to be the least common multiple of 12 and 4. And the least common multiple of 12 and 4 is 12. Right, if we think of multiples of 12, be 12, 24, so on. Multiples of 4 would be 4, 8, 12, 16, 20, 24, and so on. Right, the first multiple they have in common is 12. So the LCD of 12 and 4 is 12. That means our first fraction, 11/12, can stay as it is, right? When we're converting the fractions to the least common denominator, if it already has that denominator, it just stays as it is. We don't have to do any work on it. So we're gonna need to only convert our second fraction. We're gonna convert that 3/4. We're gonna raise it to 12ths. So what do we need to multiply 4 by to make it a 12? Well, we need to multiply it by 3, right? 4 times 3 gives us 12. And so we do the same thing to the numerator. 3 times 3 gives us 9. So 3/4 means the same thing. It is equivalent to 9/12. Okay, so both of my fractions now have that least common denominator. Now I'm ready to do my subtraction. So I'm going to rewrite my problem. Using my newly converted fraction, so 11/12 minus 9/12. If you have 11/12 and I take away 9 of them, you are left with 2/12. Okay, so we did our subtraction, and now we check and see if we can simplify. So 2/12. Is there a number that will go evenly into 2 and 12? Do they have a common factor other than 1? Yes, they do, right? They have a common factor of 2. So we can take 2/12 and we can simplify by dividing by that common factor. So instead of raising our fraction, we're reducing or simplifying our fraction. And we end up with 2 divided by 2 is 1, and 12 divided by 2 is 6. So our final answer here is 1/6. All right, now let's add and subtract with decimals. Most of the time on the GED test, if you are adding and subtracting with decimal numbers, it's probably going to be on the part of the test where you have access to your calculator. So that might be the quickest way to do it is with your calculator. But if you don't have a calculator handy or you want to double check your work, you can do it by hand. So when you are adding and subtracting decimals by hand, basically the same rules apply as with whole numbers. Is your place values must be aligned. That's the most important thing. So you line up your numbers and then you add or subtract as usual, and then you don't forget to bring down that decimal point in your final answer. So let's take these two numbers as an example. 52.25 plus 40.9. So right, the 40 gets lined up with the 52, the points line up, and the 9. Again, some people like to fill in any empty spaces with zeros. You can absolutely do that if you find that helpful. And now we add, so 5 plus 0 is 5. 2 plus 9 is 11, so 1, carry the 1. 2 plus 0 is 2, plus 1 is 3. And 5 plus 4 is 9. And then we don't forget to bring our decimal point down. So our final answer is 93.15. Piece of cake, right? All right, so now let's get on to multiplying and dividing with fractions. So to multiply, there's two main strategies that you can use. One strategy, the first strategy we're going to go through, I think is nice if you want to remember like a simpler process. So if you don't want to remember as many steps. The second one we're going to look at is nice because it keeps your numbers a little bit simpler to work with. So you might have to incorporate some more steps into your memory, but the numbers you end up working with are simpler and smaller. So let's try the first one. To multiply fractions, one way you can do it is just to multiply straight across and then simplify your numbers. So let's try that. We've got 4/5 times 3/8. We do 4 times 3 is 12. And 5 times 8 is 40. And anytime we're working with fractions, our final step is always to simplify or check and see if we can simplify. So 12 and 40, what is their greatest common factor other than 1? Do they have a greatest common factor other than 1? Yes, they do, right? They share a factor of 2 and they also share a factor of 4. So I'm gonna divide by the greatest common factor here. Divide both these numbers by 4. Twelve divided by 4 is 3. And 40 divided by 4 is 10. So our final answer is 3/10. So that's the first way to do it. It's just to multiply straight across and simplify at the end. Second strategy, second way that you can approach multiplying fractions is basically, instead of doing the simplifying at the end, you can do the simplifying at the beginning. And oftentimes you'll see that called cross-canceling with multiplication. So we can cross-cancel first and then multiply straight across. With cross-canceling, what we're doing is we are checking the diagonals of our multiplication problem to see if we can simplify. So let's look at 3 and 5 first. So 3 and 5, can we simplify those two numbers? Do they have a greatest common factor that's larger than 1? No, they don't, right? 3 and 5, the largest factor they have in common is 1, so we can't do anything with them. What about 4 and 8? 4 and 8 have a greatest common factor of 4, right? 4 will go evenly into both of those numbers. So I'm going to simplify those two numbers. 4 divided by 4 will become 1, and 8 divided by 4 will become 2. So I just cross-canceled, and now I'm ready to multiply straight across. So 1 times 3 is 3, and 5 times 2 is 10. And we arrived at the same answer we got before, which is good, right? No matter how we do it, if we're multiplying the same two fractions, we should end up with the same answer at the end. So either way you do it, you get to that answer of 3/10. It's up to you which one you prefer. I myself prefer the second way, again, just because you're basically doing the same things, you just are dealing with smaller numbers the whole time. All right, and then to divide with fractions, first thing you do is you flip the second fraction in your problem and you change the division to multiplication, and then it's just a multiplication problem. So to divide fractions, you change it into a multiplication problem, also remembering to flip the second fraction. So let's see that in action here. Let's say we have 4/5 divided by 3/8. So the 4/5 will stay the same. And now the division is going to change to multiplication. And that second fraction is going to flip. So we're going to take the inverse. The reciprocal, really, is what it's called. The reciprocal of 3/8 is 8/3, 8/3. So we take the reciprocal of the second fraction, we flip the second fraction, the division changes to multiplication, and now it's just a multiplication problem. So I'm going to check and see if I can cross cancel. 4 and 3. I can't cancel those. The greatest common factor they have is 1. And then 8 and 5. Again, I can't cancel those. The greatest common factor they have is 1. So I'm good to go with the simplifying there. And I'll move on to multiplication. 4 times 8 is 32. And 5 times 3 is 15. And there's our fraction. Now usually, we don't leave fractions looking like this. So This type of fraction is called an improper fraction. That might sound familiar, where the number on top is bigger than the number on the bottom. The numerator is bigger than the denominator. And we don't like those kinds of fractions for a final answer just because they're a little unusual. We just don't usually communicate using those types of numbers. Like if you asked me how far I walked, and I said, I walked 3/2 of a mile, that would be a weird answer, right? It would take you a minute to figure out what I was talking about. It would make a little more sense if I said I walked 1.5 miles. So we don't usually leave our answers looking like this. What we would do is we would take this improper fraction and we would change it to a mixed number. So a mixed number is a mixture of a whole number and a fraction. And so basically what we're doing is we're taking the whole numbers that are hiding inside of this fraction and we are separating them out so that we know they're there. So if you think about it, 15/15 makes one whole. 15 over 15 would be one whole. Here we have 32 15ths. So how many whole numbers are hiding inside there? Well, 15/15 is one whole. If we have another 15, right, that would be two holes. So 30/15 would be two holes. And then 32/15 would be an extra 2 15ths on top of that. So that's kind of the way to think about it here. The calculation you're going to do is you're going to divide. So you're going to say, how many times does 15 fit into 32? Well, it fits into 32 times. And then we have a remainder of 2 15ths. We have 2 15ths left over. So that would be our final answer there. So anytime you end up with an improper fraction at the end of your calculations, most likely you should change it to a mixed number for your final answer. So say your answer is easy to read, easy to think about. That's also most likely what you would see in your answer choices on the test. Okay. Now let's try multiplying and dividing with decimals. So to multiply, we ignore the decimal point and we multiply as usual. And then at the end, we place the decimal point by totaling up the decimal places. So let's take a look at that. I've got 10.5 times 3.75. Again, I'm not going to worry about lining things up because I'm going to take care of all that place value stuff at the end. So just multiply your numbers and then the decimal points right there. 5 times 5, 25. So 5 carries a 2. 0 times 5 is 0, plus 2 is 2. 1 times 5 is 5. On to the next row. Place 0 there. 5 times 7 is 35. So 5 carry the 3. 0 times 7 is 0. Plus 3 is 3. And 1 times 7 is 7. On to the next row, we're going to have 2 zeros now. 5 times 3 is 15. So 5. Cross this out and say it's 1. 5 carry the 1, and then 0 times 3 is 0. Plus 1 is 1. And 1 times 3 is 3. So we'll multiply all of our numbers together. Now we add everything up. 5, 7, 13. So 3 carry the 1. 9. And then 3. Okay. So that was all whole number multiplication. We haven't done anything different from what you would do with whole numbers. Now we need to go back and think about our decimal places. So the first number, 10.5, that had one decimal place. The second number had two decimal places. And so in our final answer, we're going to take our decimal point and we're going to move it over 1, 2, 3 places altogether. So we're going to get 39.375. And now you could double check that makes sense by taking a look at your original numbers and doing some estimating. So 10.5 times 3.75, well, 10, say like, that's about 10, and then 3.75, that's about 4, so 10 times 4 will give you 40, and our final answer is close to 40. Now, if you had made a mistake and you had put your decimal point somewhere else, you would have ended up with something like 393, right? And you should hopefully be able to look at that and be like, that seems a little fishy because I should be getting an answer close to 40. All right, so that's multiplication. And then when you are dividing with decimals now, I'll be honest, on the GED test, you are not often going to need to divide the decimal numbers by hand. Most likely that would show up on the second part of the test where you can use your calculator. But it's a good skill to know. It might be useful on other tests that you need to take. So it could be useful on the TAPE test. It could be useful on a college entrance exam, something you need to do for a job, etc. So let's give it a shot here. When we divide decimal numbers by hand, we use long division. To make our lives easier is we turn the divisor into a whole number by moving the decimal points of both the dividend and the divisor. And then we do long division as usual, remember to place the decimal point in our answer. So that sounded a little bit complicated probably, all that stuff, the dividend and divisor. So let's just see it in action. I got 10.5 divided by 3.75. So I'm going to set up my long division. 10.5 divided by 3.75. So what we want to do to make our lives easier, instead of trying to think to ourselves how many times 3.75 go into 10, we're not going to do that. We're going to take that 3.75 and we're going to make it into a whole number. So we're going to move the decimal point over as many places as we need to until we get a whole number. Okay. So that's 37.5 now. One more. Now we have 375. And whatever I do to that outside number, I just do the same thing to the inside number. So I move it over one place and then 2 places. And I'm going to fill in that empty space with a 0, right? 0 means empty, means nothing. And now I'm going to rewrite my problem so I don't see all the decimal movements there. So now my new problem is 375 into 1,050. So how many times does 375 go into 1,050? Well, we can just start multiplying. So 375 times 2, that gives us 750. 375 times 3, that gives us 1,125. So it's too much. It doesn't go in that many times. It's only going to fit in 2 times. 375 times 2 is 750. And before I forget, to the last step here, right? We know ours is a whole number, so our decimal point is hiding right here. We're going to place our decimal point before we forget about it. Okay. And then we subtract. 300 left over. 375. We go into 300. What do we need to do? We need to add a 0 to work with. Bring down a number. How many times does 375 go into 3,000? Well, again, you probably don't know off the top of your head. We can do some guessing and checking. So I know 375 times 10 will be too much because it'll be 3750. So let's try 375 times 7. That gives us 2625. I might be able to do one more. 375 times 8. This is 3,000 exactly. So 375 goes into 3,000. Where do we cursor go? It is. Goes in 8 times. This is 3,000. And we have 0 left over, so we are done. So 1,050 divided by 375 is 2.8. That means that 2.5 divided by 3.75 is also 2.8. Okay, the next thing we're going to do here is we're going to go through a few word problems together. Now I am going to be posting another video later this week going through even more practice problems related to fractions and decimals. But these are just to get them started for the homework this week. So let's take a minute to read this question. It says a box of Frosty French cereal costs $4.89. Package label says that the box contains 20 servings. What is the cost of one serving for the nearest estimate? So, we've got this total cost, right, for the whole package. The package contains 20 little servings. We want to know the cost of one serving. What do we need to do? Well, we're talking about taking the whole amount and cutting it up into little parts, dividing it up. So we should divide. We should take that total cost, and then we should divide it by the number of servings. That will tell us the cost per serving. So total cost 49 divided by number of servings. We're going to follow the decimal division process we just went through. So I'm going to start by bringing up the decimal point. I divide here already a whole number. So I'm going to worry about it. Now we divide as usual. So 20 goes into 48. How many times? It goes into 48 two times. Okay, right? 20 times 2 is 40. Subtract. We have 8 left over. Bring down the next number. How many times does 20 go into 89? It goes in 4 times. 4 times 20 is 8. Subtract. 9 left over. So we need to keep dividing. In order to keep dividing, we need to have numbers to bring down. So we add some zeros here to work with. You add as many zeros as you need. Just keep adding them. So now I bring down the 0. How many times does 20 go into 90? It goes in 4 times. 20 times 40, 80. Subtract. 10 left over. Bring down another 0. Times 20 go into 100. 5 times. 20 times 5 is 100. And so we're done. We'll have 0 left over. Okay. So So this right here, 0.2445, should be the cost of one serving. We took the total cost, we cut it up into the number of servings. But this is cost we're talking about, right? So we don't want that many decimal places. We want to round to the nearest cent. So 0.2445 to the nearest cent. What is that going to be? It's going to be 24 cents. So this cereal is about 24 cents per serving. So how did we know that this was a division problem? We knew this was a division problem because we were given a total amount. We were told that we could break it up into 20 equal parts. And we wanted to know the cost of those equal parts. Anytime you have a problem that is talking about a total amount that you're cutting up into little pieces, you want to start thinking about division. All right, number 2. The sender parking garage charges $2.50 for the first hour and $1.25 for each additional half hour. How much cost to park there for 2.5 hours? Well, 2.5 hours, let's go through this. So the first hour is $2.50. The first hour is $2.50. So I'm going to go through and start labeling my hours. Hour 1 is going to be $2.50. I'm just going to count up the charts. So that's after the first hour, we spent $2.50. Now it says $1.25 for each additional half hour. So after the next hour, after the end of 2 hours, how much more have we spent? Well, that would be another half hour, just 1.25, another half hour after that. So it's going to be another $2.50. And another $2.50. And so in total, we spent $5. So they're making it seem like we're maybe getting a good deal after we spend the first hour in the parking lot, but we're not actually, right? It's the same rate by half hour. They're just trying to break it down for us. Hoping that we're not noticing we're paying the same amount as they say in the parking garage for a long time. All right, so far we've gone up to 2 hours. Now we've got last half hour remaining. So 2.5 up to the end of our time. Well, it's going to be another $1.25 on top of that, right? So we're going to end up with $6.25. We're going to have spent $6 and 25 cents at the end of our 2.5 hours. So $2.50 for the first hour, and then $1.25 for each additional half hour. How many half hours were there that we added on? We added on 3 more half hours, right? 1.5 hours, 2 hours, 2.5 hours. We did 3 more half hours for a total of $6.25. All right, last problem. On the number line below, what is the value of A minus B? Well, as we said before, any problem that involves number lines, first thing you should do is you should take some time to inspect your number line, get familiar with it. So I look at my number line, I see it starts at 0, and I've got a whole number here, I see I've got 1, and I've got that whole number split up into little parts. So I want to determine what does each little part represent. Well, I'm going to count up my parts. So 1, 2, 3, 4, 5, 6, 7, 8. So this whole has been split up into 8 parts. We're dealing with 8 here. If you wanted to, you could go through and label. This would be 1/8. This would be 2/8. That is 1/4 if you simplify it. And the next one we have would be 4/8. Another name for that is 4 1/2. 5/8. Also, we'll simplify to 3/4. And then 7/8. Well, that labeling we just did there was not required. You don't have to do that as well. You just need to make sure you understand which little piece represents so you can identify what E is and what A is. So B is 4/8 and A is 7/8. Let's go ahead and subtract, right? So this is the value of A minus B. A minus B. This is going to be 7/8 minus 4/8. I'm choosing to say 4/8 instead of 2/4 because when I add or subtract, I want my denominators to be the same, right? It makes my life easier to choose 4/8. And then my final answer is 3/8. But is it my final answer? I want to double check and see, can I simplify this? Is there a number that goes evenly into 3 and 8 other than 1? Nope. The only thing I could divide by is 1. I don't need to bother with that. So my final answer here is 3/8. Alright guys, so thank you for joining me in this lesson. What do you have to do this week? Well, you want to make sure you're reading all of our posts on Google Classroom. So you had your introduction post on Monday, your vocab list and online learning links on Monday. The vocabulary quiz went on Tuesday, and study skills will be on Thursday. And then you have your 3 assignments to work on this week. So the problem of the day on Monday, the worksheet Wednesday on, you guessed it, Wednesday. And then your final problem of the day will be on Friday. And make sure if you plan on coming in person that you send me a message to let me know. All right. So take care, and I will hopefully talk to you all very soon.